So we've been talking about linear regression. Now we're going to talk about polynomial regression. So recall that linear regression, that we had data that was in a straight line, and we had the form y is equal to ax plus b. Now we're going to talk about a couple of different regression models today. We're going to talk about quadratic, cubic, and quartic regression models. Okay. So we've got our model type on the left-hand column, and I've got our scatter plot on the right-hand side. So I'm going to kind of show you what these types of regression models look like. So for quadratic, now our form for quadratic is y is equal to ax squared plus bx plus c. The highest exponent term for this one is x squared. So quadratic data that follows a quadratic pattern is in the shape of a parabola. It could be opening up or it could be opening down. So let's just draw a random scatter plot. That kind of looks like a parabola. And this one's opening up. Now, just the same, it could be opening down. So it's curved. Now, cubic data is of the form y is equal to ax cubed plus bx squared plus cx plus d. Now, the highest exponent term for that one is cubed. And the way that the cubic data goes is something like this. So this is just an example. Of course, you can have something that looks kind of like that as well. And then the last type we're going to talk about is quartic. So the form for quartic is y is equal to ax to the fourth power plus bx to the third power plus cx squared plus dx plus e. So the highest exponent term for that one is x to the fourth power. Now quartic, it can either look like an M or a W. So let's just draw an example of quartic. Let's make this one look like an M. So if you have data that kind of looks like this in this pattern, you would want to do a quartic regression model. So what we need to do in these cases is we need to take a really good look at our scatter plots and figure out what kind of model it looks like before we actually create our regression model. Now, this is just like linear regression in the sense that we're going to use our calculator for everything. So you're going to put the data in like you usually do. You go to Stat, Edit, put it in L1 and L2. Then we're going to have to look at our scatter plot. Here's where things change. We have to determine which regression model would fit the data the best. So we can just take a glance and see what what the data looks like. And then number 3 said, instead of going to for lin reg, now if you go to calc, stat over to calc, there's actually these 3 choices. 5 is quad reg, which means quadratic regression. 6 is cubic reg, which is cubic regression. And 7 is quart reg, which is quartic regression. So we're going to choose the one that would fit our data, and it's going to spit out those constants, those letters in front of our variables. It's going to spit out those numbers for us so we can write our regression model, just like before. Alright, so pull out your notes page. So let's take a look at this one. So the notes tell us, first we got to determine which type of regression we have, and then we're going to create the regression model. So let's go ahead and put this data in our L1 and L2. Now after we put the data in L1 and L2, we need to change our window in order to take a look at our data. So press window, and let's set our x min to something that's smaller than the smallest x. Our smallest x is -2, so let's set our x min to -3. We set our x max to something that's bigger than our biggest x. Our biggest x is 3, so let's set our x max to 4. And scroll down. We're going to set our y min now. Our smallest y value is -9, so let's make it -10. And our biggest y value is 54, so let's just make it 55. And press graph. Now, this data looks like it's in the shape of a parabola. So what we have here is we have a quadratic regression model. So we can write, we have a quadratic regression model. So now that we've determined that we have quadratic regression, we're going to press Stat, go over to Calc, and this time we're going to go to number 5, Quad Reg. Press Enter and press Enter until our screen shows us what we're going to pick for A, B, and C. Wow, this one's got really pretty numbers. So our quadratic regression model is y is equal to 8x squared plus negative 3x minus 9. Now, I wrote plus and negative. You can write minus 3x, and it's the same thing. Okay, so let's take a look at number 2. The first thing we want to do is put this data in our L1 and L2. Once we have our data in L1 and L2, we need to adjust our window. So, press Window, the x-min, our smallest x value is negative 1, so we can make our x-min negative 2. Our biggest x value is 3.5, so we can make our x max 4. So scroll down and do the y's. The smallest y value is negative 1, so we got to make it smaller than negative 1. So let's choose negative 2. Our y max, our highest y value is 13, so we need to pick something bigger than 13. So let's pick 14. So press Graph and take a look at it. Now this looks like quartic. We have a quartic regression model. So let's write quartic regression. Okay, so now we've got to create our model. So Stat, over to Calc, and we're going to go to 7, quartic regression. Press Enter until your model pops up on your screen. Now these are kind of long. So let's do 4 decimal places, like usual. So A is 1.0326 x to the 4th power plus negative 5.1585 x to the 3rd power plus 6.0833 x squared plus 0.2331 x plus 0.9411. Whew. And there's our quartic regression model for this one. Okay, so let's look at number 3. Let's go ahead and put our data in L1 and L2. Once we get our data in L1 and L2, press Window. We need to pick our x-min. Our x-min, our smallest x value is 5, so let's pick something smaller than 5. So let's choose x-min to be 4. Our biggest x value is 16, so let's choose x max to be 17. Our smallest y value is negative 3, so let's make our y-min negative 4. And then our biggest y value is 9, so let's make our y max 10. So press Graph and take a look at it. So this looks like a cubic regression model. Now let's create our cubic regression model. So go Stat, over to Calc, and this time we're going to select 6, cubic reg. Press Enter until your model pops up on your screen. So our model is y is equal to 0.0909 x cubed plus negative 2.7009 x squared plus 24.6299, so let's do 6300 x, and then plus negative 65.2050. And there is our cubic regression model for that data. Okay, so moving on to number 4. Number 4 says consider the set of data. And it's asking us what quadratic polynomial function models the data, and then they also want us to pick cubic. And then they want us to figure out which one we think is a better model for our data. So let's go ahead and take our data and put it in L1 and L2. Okay, after you put it in L1 and L2, let's set our window. Our smallest x value is negative 2.5, so let's set our x min to negative 3. Our biggest x value is 1.5, so let's set our x max to 2. Our smallest y value is 2, so let's set our y min to 1. And our biggest y value is 23, so let's set our y max to 24. So take a look at it. If you had to pick what type of regression model you think it looks like the most, which one do you think you would pick? Honestly, I would pick quartic. But let's see. Let's answer these questions. So let's do quadratic first, and let's see how that models the data. So we go stat, over to calc, and we're going to go to quadratic. So our quadratic model that would fit this would be y is equal to 1.9913 x squared plus negative 1.74199, so let's do 420 x, and then plus 2.7567. Now remember yesterday how we talked about the r squared? Let's just jot down what the r squared is for this one. The r squared is 0.8749, which is 87.49% of the data explained by this model. So now let's do the cubic. So go stat, over to calc, and we go to number 6, cubic. Now our cubic model is negative 0.9562 x cubed plus 0.5569, so let's do 0.5570 x squared plus 0.3617 x, and then plus 4.0476. Now I'm kind of running out of room, sorry. Now the r squared for this one is 0.9373. So that is 93.73%. So if we take a look at the r squareds, we're going to kind of compare these. This says that this model explains 87.49% of the data. And this says that this model explains 93.73% of the data. So if you're ever in a situation where you don't know which model, figure out which ones you can narrow it down to, and you can calculate both of these and look at the biggest r squared value. So based on this one, actually, cubic would be more appropriate. Because it has a higher r squared value.